guys, Ms. Miklos here, and today we are talking about factoring and solving. And I know a lot of you are thinking, wait, didn't we do that last chapter? And we did, and I want to quickly just review what we learned last chapter. So last chapter, we talked about how to factor binomials and trinomials. And the first thing that we always looked for was a GCF. Secondly, we looked for patterns. And the two patterns we learned were perfect square trinomials and difference of squares. And then lastly, we talked about opposite of FOIL. And if you guys need more help on those concepts, please watch the previous video that you can find that is just on factoring quadratics. Today we're taking it a step up and we're going to be dealing with some things that are not quadratic. So the first new thing we're going to learn today are two brand new patterns. And our two patterns are actually very similar. Our first is sum of cubes and our second one is the difference of cubes. And if we look at these are both binomials that have perfect cubes. One is added together and one is subtracted from one another. And we will kind of see that this pattern is going to be exactly the same. And we're going to learn a little acronym to help us figure out what the sign should be. So if I am figuring this out, our pattern is going to be x, y, x squared, x times y, y squared. And notice that I'm not putting in any signs yet. Our other pattern is going to be exactly the same, x, y, x squared, x times y, y squared. And now we need to figure out what should be the signs in here. And in order to remember that, we are going to think of the word SOAP. And we're going to hear what SOAP stands for. SOAP, our S value in SOAP, stands for same. Our O value in SOAP stands for opposite. And AP in SOAP stands for always positive. So this acronym SOAP, same, opposite, always positive, is going to tell us what to put in here. Now when I'm saying same, I mean the same sign as our original binomial. So in this first one, I would need to put a plus because that's the same sign, then a minus because that is the opposite of our sign, and finally, it is always positive. For difference of cubes, this time our first sign is going to be a minus because that is the same. Opposite would be a plus and always positive. Okay, so this is definitely a pattern we need to memorize. We need to know this. So x, y, x squared, x times y, y squared. And that's the same for both of these. And then our signs go same, opposite, always positive. So we're thinking of SOAP. Let's actually try out a problem here. So here I have a binomial. As always, the first thing I'm always going to look for is there a GCF? And looking at this, I don't believe that there is. So now, I notice that this is cubed, so I'm thinking that these might both be perfect cubes. So I need to figure out what is my A value and what is my B value. And what I mean by that is what is the cube root of x cubed, and that would be x. And what is the cube root of 343, and that ends up being 7, because 7 cubed is 343. So if I'm following my pattern, I know it goes A, B, A squared, A times B, B squared. And my operations follow SOAP. So I'm going to have same, opposite, always positive. Now normally when I have something quadratic, I still need to look and see if I can factor this further. And I'm letting you know whenever we factor using this difference or sum of cubes, this trinomial here is never factorable. Okay, in fact, if we use the discriminant, we would find that those answers are going to be imaginary. X plus 7 times x squared minus 7x plus 49 is our final answer. Let's do another one here, x cubed minus 1. First thing I'm looking for, I don't see a GCF, But I do see that I have a perfect cube once again. So I'm thinking that our A value is x and our B value is 1. Because the cube root of x cubed is x, the cube root of 1 is 1. So if I'm following my pattern, I know it's going to go A, B, A squared, A times B, B squared. SOAP tells me same, opposite, always positive. So I have x minus 1 times the quantity x squared plus x plus 1. Let's do one final example before we move on to our next topic. So once again, looking at this, we do not have a GCF. However, I notice once again I have a binomial and I have perfect cubes. The cube root of 27x cubed is 3x. And the cube root of 64 is 4. So if I am following my pattern, I know it's going to go A, B. And this is the tough one. I need to think, what happens when I square 3x? And I actually get 9x squared. And a way to double check this, if I FOILed, or in this case, distributed things out, just like we did in our last lecture, I know I need to get 27x cubed. 3x times 9x squared gives me 27x cubed. Okay, so following along, 3x times 4 is 12x, 4 squared is 16. Following SOAP, I'm doing same, opposite, always positive. So this would be our final answer. The next thing we're learning here, we kind of outlined the first 3 steps. Step 1, GCF. Step 2, pattern. Step 3, opposite of FOIL. And here's a new step. Step 4, we are going to do something new called factor by grouping. And we are going to do this when we have 4 terms in a polynomial. And really the whole concept behind this is dealing with taking out common factors. So before we even get into this, let's just kind of look at something. If I had x cubed plus x squared, we would say that there is a common factor of x, and I'm left with x squared plus 1. So we're pretty familiar with this concept of factoring out a common factor. If I distributed back, I would get our original polynomial. And in a more complex way, we're going to be using this exact concept. X cubed plus x squared plus x plus 1. Right away, I notice this has 4 terms, so I'm thinking factor by grouping. And what factor by grouping means, it means that I'm going to go ahead and put this polynomial into 2 different groups. So I'm taking my first 2 terms and putting them in a group, plus I'm going to take my second 2 terms and put them in a second group. And the reason why this is helpful now is because if we look at this polynomial as a whole, we do not have a GCF. But if I look at it in 2 smaller pieces, we can definitely find some GCFs. In fact, if I look at x cubed plus x squared, that is what we just did. And I can factor out an x squared, and I'd be left with x plus 1. Okay, and then x plus 1, there's really nothing I can do. Now, looking at this, we actually have 2 different terms here. Even though it looks strange, technically this is like a binomial because I have my first term plus my second term. And if I'm looking at these 2 terms, I notice that both of them have this x plus 1. So I'm going to go ahead and factor out the x plus 1. When I take an x plus 1 out of this first term, I am only left with x squared. When I take an x plus 1 out of this second term, I am left with 1. And just a reminder, if I really wanted to double check if this worked, x plus 1 times x squared is what I have here, and x plus 1 times 1 is what I have here. So all we did was factor this out. Now I need to look at these 2 and see if there's anything we can do further. X plus 1 is linear, so I know I'm good. This quadratic equation, I know I cannot factor this because this is addition. There are no factors of positive 1 that add up to be 0. So my final answer here is x plus 1 times x squared plus 1. Let's go ahead and do another one here. So once again, I notice here I have 4 terms. So I'm going to group my first 2 terms together, and then I'm going to group my second 2 terms together. And if I look at this first group, I notice that both of them have an x. So I'm going to take an x out, and I'm left with 2 minus q. If I look at this second group, I notice that both of those have a 4y that I can take out. And when I take that 4y out, I am left with q minus 2. So I've gone ahead and now I just have my 2 separate terms. However, this time I don't have a common factor because I have 2 minus q and I have q minus 2. And we call these values opposites because both terms are completely opposite from one another. Whenever we are dealing with opposites, I need to go ahead and factor out a negative 1. And to be completely honest, it does not matter which of these I factor a negative 1 out of. I normally choose the second one. And let's just kind of go ahead and look and see what that does. So if I take a negative out now, I have negative 4y, and that leaves me with negative q plus 2. Now I notice these 2 factors are actually the same exact thing, even though they're written in a different order. So I have 2 minus q times x minus 4y. And this would be our final answer. Okay, so once again, I broke it into 2 groups. I factored out the GCFs. This time, what I was left with in the parentheses was not the same. They were opposite, so I had to factor out a negative 1. And then I had something in common that we could take out. Let's do another one here. So first thing I'm doing, I'm grouping together x cubed minus 2x squared. I'm going to group together negative 9x plus 18. I knew I was going to use grouping here because I have 4 terms. Looking at our first group, I'm going to factor out an x squared, and I am left with x minus 2. Now, I can kind of foresee here that I do have a 9 in common, but if I take a 9 out, I'm not going to have x minus 2. So what I'm actually going to do is take out a negative 9, and when I take out a negative 9, it gives me x minus 2, because negative 9 times x is negative 9x. Negative 9 times negative 2 is 18. Now if I look at these 2 terms, I have an x minus 2 in common, and I'm left with x squared minus 9. As always, I always need to look and see if I can factor further, and this time, my x minus 2 is good, but I can factor this further. So this is going to become x minus 2 times x plus 3 times x minus 3. And that would be our final answer. So that was a quick overview of how to do our new factoring methods. Now on our homework tonight, the other thing we're going to be doing is finding the real number solutions. And if it says real number solutions, that means I only care about our x-intercepts, and I'm actually going to throw away all of our imaginary numbers. Okay, we really do not care about our imaginary answers in this case. I only care about the real numbers. So let's go ahead and get started. So here I have 2x to the 5th plus 24x equals 14x cubed. So the very first thing that I'm going to do is get everything equal to 0, because I know that I want my y value to equal 0. And obviously today we are factoring, and this looks kind of ugly because I have this x to the 5th, which is gross. But let's go ahead and look at it anyways. First of all, we know that we have a possibility of having 5 answers, and the reason why I'm saying a possibility is because I don't care about imaginary values. I only care about real numbers today. So I'm going to try and factor this, and the first thing I always look for is a GCF. And if I look at these three terms, I notice that they all have an x in common. So if I factor out an x, I'm left with 2x to the fourth minus 14x squared plus 24. And in fact, I notice that they have more than just an x in common. They actually have a 2x in common. So this really should just be x to the fourth minus 7x squared plus 12 is equal to 0. And a lot of times when we're taking out a GCF, this might happen where I take something out and then realize, shoot, I have more inside, and that's fine. I can just go ahead and do that in my next step. Now, this trinomial right here, we are actually going to factor that by using opposite of FOIL. So we're really used to dealing with x squared, x, and a constant. Here I'm doing that same concept. So I need to think what would multiply to be x to the fourth, and that would be x squared times x squared. What factors of 12 add up to be negative 7? And that would be negative 4 and negative 3. So now that I've done this, okay, there's a few things I could do. I could factor this further if we want, or at this point I can set all of these equal to 0, which is what I'm going to do. So I'm going to say 2x equals 0, x squared minus 4 equals 0, and x squared minus 3 equals 0. So my first answer here is going to be x is equal to 0 because when I divide both sides by 2, I get 0. My second time, hooray, we have quadratic functions. So we know all the different methods. Some of you might choose to factor this further, x plus 2, x minus 2. So then I have x plus 2 equals 0, x minus 2 equals 0. So x is 2, and x is negative 2, and x is positive 2. And our last factor here, we actually have another quadratic function, and this time I'm going to use square roots to help me out. So I'm going to add 3 to both sides. When I square root both sides, I know I need to put plus or minus, so I get x equals plus or minus radical 3. Okay, and we could have solved these two in different methods. I just thought those were the easiest. Regardless, we notice I actually get 5 different answers here. And we're not going to graph this, but if I wanted to graph it, it would tell me that there are 5 x-intercepts for this particular function. Problem number 2, we have x cubed minus 27 is equal to 0. So this time it's already said equal to 0, so I'm just going to go ahead and look at x cubed minus 27. And to me, that looks like our difference of cubes pattern. In fact, off to the side, I'm going to write our a and our b values. Our a value here is x, because the cube root of x cubed is x. Our b value is 3, because the cube root of 27 is 3. So we know our pattern goes a, b, a squared, a times b, b squared. And our signs are SOAP, so same, opposite, always positive. At this point, I'm going to set these both equal to 0 because I know that x squared plus 3x plus 9 is not factorable. So I'm going to go ahead here and solve x minus 3 equals 0, and I get x is equal to 3. So I know that that is one of our 3 answers. Now our other 2 answers are coming from here. The question is, are they real or are they imaginary? I'm going to go ahead and use completing the square because I personally like that method the best. So I'm subtracting 9. Now I know I need to take my middle coefficient, divide it by 2 and square it. So I'm adding 9/4. And all of a sudden I am foreseeing something here. Looking at this value, I notice that this is going to give me a negative number. And to be honest, I don't really care what it is because I know my next step after I factor is going to be to square root. And we know the square root of a negative number is imaginary. Our directions told us to only find the real values. So I know at this point I can actually stop and I don't need to do anything else. And in fact, what some of you guys might want to do is use our discriminant. And I know last chapter it was kind of like, why do we need to know this? This is a good example of one where instead of going through the motions of actually solving, I can figure out pretty quickly if this is going to be positive, negative, or zero and what I should do from there. And if I'm using the discriminant, often I will use the quadratic formula to solve because I've already solved part of it. So this time I'm going to do 3 squared minus 4 times 1 times 9. And we can definitely see that 9 minus 36 is going to equal a negative number, which we know gives us 2 imaginary values. So that means that I would not need to actually solve this because I only care about our real numbers. So we're kind of tying in a bunch of stuff in our lesson today. So our only answer here is x equals 3. Okay, so moving on, this time I have 4 terms, which means we are most likely going to factor by grouping. The very first thing I notice though is that these are all negative, and since we have an equation, I'm going to divide everything by -1. We cannot do this when we are just factoring because when I'm just factoring, I have an expression, so I can't take things out. Here, dividing by -1, I'm dividing both sides of the equation, so it's totally fine. Now I'm going to look and see, do I have a GCF? And we actually do not have one. So I'm going to go ahead and set this up for factoring by grouping. And I just think this looks a lot nicer with positive values. Looking at our first 2 terms here, I notice that they have a 2x squared in common, and I am left with x plus 2. In my second one, I have a 3 in common, and I'm left with x plus 2. So when I factor this further, I can take an x plus 2 out of both of these factors, or both of these terms, I should say, and I'm left with 2x squared plus 3. Now I actually cannot factor this any further, so I'm going to go ahead and just set these both equal to 0. And I know x plus 2 equals 0 means that x is -2. On my other one, I get 2x squared equals -3. And at this point, what can you guys see about this? For me, I'm noticing that this is going to be a negative value, and a square root of a negative is imaginary, so I can stop because we only care about our real answers. Number 4, we have x cubed minus 3x squared is equal to 0. And this is really similar to one of our problems we had on our Chapter 5 test, except for the fact that this is cubed, it's not squared. It's already set equal to 0, so I'm going to try and factor this. First thing I notice is that I have a GCF of x squared, so I get x minus 3 equals 0. So I'm going to say x squared equals 0, x minus 3 equals 0. So we know that we get x is equal to 3. X squared equals 0, what that's really telling me is that we have 2 answers here, and I end up getting 0 2 different times. Okay, and the significance of getting a double 0, first of all, we knew we should have 3 answers at the beginning, and when I graph this, we learned last chapter, that means it bounces off the x-axis. Now, if you just told me x equals 0 and x equals 3, I would be completely fine, but this is signaling to us our exact 3 values that we get for our x-intercepts. And our final problem of the day, 3x squared plus 11x plus 6 is equal to 0. Yes, this is a throwback to last chapter because this is quadratic. So I want to double check, is this something that is factorable? So last chapter we said I can do 3 times 6, which gives me 18. Are there factors of 18 that add up to be 11? And yes, there are, because 9 and 2 would work. So I'm going to go ahead. Since I did not have a GCF, I need to go ahead and just start factoring this using opposite of FOIL. I know 3x and x are the only things we can multiply to get 3x squared. And factors of 6 that add up to be 11, I'm going to go ahead and do plus 2 and plus 3. So this is 9x plus 2x, which is 11x. Now I'm going to set both of these equal to 0. So I get 3x equals negative 2. So x is negative 2/3. And I get x is equal to negative 3. Okay, so hopefully this is a good refresher for you guys on factoring. We definitely learned 2 new factoring methods, factoring by grouping and sum and difference of cubes. So this is the first method that we are going to use in order to solve higher order polynomials. When we get back from Thanksgiving break, we will really get into some tougher ones where factoring may not necessarily work. So we're going to have to use some additional methods. But what I want to point out is we are going to continue to use quadratic functions and how we solve quadratic functions in this entire chapter. So if that's something you struggled with, I would definitely rewatch some of those videos so you are on top of things.